Same SSID, different BSSID. Open security where the corporate network requires WPA2. An attacker just stood up an evil twin access point in your conference room. Deauthenticated every client off the legitimate AP. Clients automatically reconnected to the rogue. The attacker is now man in the middle on every connection. Welcome to Wireless and Intrusion Forensics, where 802.11 frame analysis, DHCP log correlation, firewall logs, and proxy logs revealed UHO was on the network, when they were there, and what they did. 802.11 frame types. 3 categories: management frames, beacons, AP broadcasts, probe requests, client looking for an AP, probe responses, authentication, association request, client joining, deauthentication, disconnects a client. A flood of these is a denial of service attack, used in evil twin setups. Disassociation, similar to deauth. Control frames, ACK, RTS, CTS. Flow control and the hidden node problem. Data frames, the actual payload, where the network traffic lives. Wireshark filters for wireless. WLAN, all 802.11 frames. EBULAN.FC.type equals 0, management, equals 1, control, equals 2, data. BULAN.FC.subtype equals 12, deauthentication frames. The key deauth filter. WLAN.BSSID equals MAC, frames from or to a specific AP. WLAN.SA equals MAC, frames from a specific device. EAPOL WPA handshake frames. The 4-way handshake, capturable for offline cracking. Monitor mode versus manage mode. Manage mode is normal client mode, receives only frames addressed to your MAC or broadcast. Monitor mode is promiscuous wireless capture, receives all frames on the channel regardless of destination. Required for forensic wireless capture. Enable monitor mode on Linux. Sudo airmon ng start LAN 0 creates LAN 0 mon, or manual. Set the interface down. Set mode to monitor. Bring it back up. Capture with TCP dump on the MON interface, or with arrow dump ng on a specific channel. Channel 6-W evidence file. Note about wireless cards. Not every Wi-Fi adapter supports monitor mode. Alpha cards with Atheros or Raylink chipsets are the standard for forensic wireless capture. Built-in laptop Wi-Fi often does not support monitor mode on most operating systems. Rogue access, point detection. 2 attack types: deauthentication, flood. Attacker sends spoof deauth frames to disconnect clients from the legitimate AP. Reason code 7 is commonly used. Class 3 frame from non-associated station. Detection. Wireshark filtered bolan.fc.subtype equals 12. Large number of deauth frames. Indicators. MAC of the deauth sender does not match the AP MAC. Multiple clients disconnected simultaneously. Evil twin. Attacker creates a rogue AP with the same SSID as the legitimate network, broadcasts with stronger signal or after deauthing clients from the legitimate AP. Clients connect to the rogue. Attacker performs man in the middle. Detection, same SSID with different BSSID. Multiple APs on the same SSID visible simultaneously. New AP on a channel not used by the legitimate AP. Check arrow dump ng output for duplicate SSID with different BSSID. Also rogue indicators. Unusual channel. Open security where corporate requires WPA2. Different RSNIE in beacon frames. Unusual MAC OUI. DHCP log analysis. The primary tool for IP-to-MAC address mapping. Essential for attributing network activity to a specific device. Windows DHCP server log format, date, time, description, IP address, hostname, MAC address. Event codes to know. Code 10, assign, new lease. Code 11, renew. Code 12, release. Code 13, DNS update request. Code 15, DNS update succeeded. Linux ISC DHCP server logs at /var/log/syslog on Debian and Ubuntu. grep DHCPD pipe grep DHCPAC to find lease grants. The correlation process. Step 1. Identify suspicious IP from IDS, firewall, or proxy logs. Step 2. Search DHCP logs for assign or ACK entries for that IP at that timestamp. Step 3. Note the MAC address and hostname. Step 4. Correlate MAC to a physical device. Step 5. Map device to user through Active Directory or VPN authentication logs. DNS log forensics. Windows DNS server. Enable debug logging. Log at c:/windows/system32/DNS/DNS.log. Bind on Linux. Configure query logging in /etc/name.conf. Analysis for C2 detection. Find high-frequency queries to the same domain. Sort pipe-unique-c pipe-sort-rn. Find unusually long domain names. Awk length greater than 50. Find domains with many unique subdomains. DGA or tunneling indicator. Find DNS TXT record queries. grep TXT. Workstations querying TXT is a red flag. Then NXDOMAIN analysis. High rate of NXDOMAIN, non-existent domain, responses from a single host. Primary indicator of DGA behavior. DGA malware generates random domains and queries them. The C2 server registers 1. The bot keeps querying until it hits the valid one. Count NXDOMAIN responses per source IP. Top sources by NXDOMAIN count are your DGA suspects, firewall and proxy logs. Eptables on Linux logs, SRC, DST, Lian, Proto, SPT, DPT, Window, SynFlag. Cisco ASA, %ASA 4-10602-3 for explicit deny by ACL. Port scan detection in firewall logs. Same source IP connecting to many destination ports rapidly. Many DNI entries from a single source. Sequential pattern across ports 21, 22, 23, 25, 80. Proxy log analysis. SQUID format includes timestamp, duration, client IP, result, bytes, method, URL, destination. Find large downloads. awk on the bytes column. Find specific user agents. grep SQL map or grep nicto or grep curl. Find requests to suspicious domains. Sort by frequency. Find POST requests. May indicate exfiltration. Find directory traversal attempts. grep ... Find long URLs. SQL injection. XSS. Path traversal indicators. User attribution. If the proxy requires authentication, username is in the log. Otherwise, correlate client IP-to-user via DHCP chain. VPN forensics. Windows VPN Razman. Event ID 2225. VPN connection established. Event ID 2226. VPN connection terminated. Log at Event Viewer Applications and Services logs. Microsoft Windows Razman. Open VPN logs at /var/log/openvpn.log. Cisco AnyConnect logs at /program data /Cisco AnyConnect. DART for log collection. Then split tunneling, the forensic limitation. Split tunneling. Only corporate bound traffic goes through the VPN. Internet traffic goes direct. Internet activity of VPN connected users may not appear in corporate logs. Full tunnel. All traffic routed through VPN. Complete visibility. VPN log correlation chain. VPN server log. Username, connection, timestamp. Assigned internal IP. External IP. Map the internal VPN IP to user. Attribute traffic from that IP. Then enterprise wireless radius. Windows NPS log at c:/windows/system32/log files. Radius provides the definitive username to MAC address mapping in enterprise wireless. The forensic gold for Wi-Fi attribution. Wireless and intrusion forensics in one breath. Monitor mode for wireless capture. 802.11 frame filters in Wireshark. Deauth flood detection. Evil twin recognition. Same SSID, different BSSID. DHCP logs for IP to MAC mapping. The attribution chain. NXDOMAIN floods for DGA. TXT queries for tunneling. Firewall logs for port scans and connection patterns, proxy logs for URLs, user agents, large downloads, VPN logs and split tunneling limitations, radius for definitive wireless attribution. Domain 8 is complete. Next up, Domain 9, Malware Forensics. Objective 9.1, Static and Dynamic Analysis, PE file structure, volatility plugins, Yara rules, Koku Sandbox, the Malware Analyst Toolkit,